In this next video, we're going to look at another physical concept that is related to distance and displacement. So at the beginning here, an example is given, and I just want you to look at the distance and displacement. So pause the video, try it out, and when you're ready to see the solution, resume the video. And so when I did this, I got, so I drew a diagram and all that stuff. I got a distance of 1100 meters because I was just going the perimeter, the actual path traveled. And then displacement is just comparing, again, beginning to end, and I didn't use time. We'll get to that in a minute. And so distance, I got 1100. Displacement would be the magnitude of those two sides, or those two components, because this would be represented as 300 comma minus 800, and then we go on with our life, and I gave an angle to of 315 degrees because again it would go all the way around here. Okay, so great. Next, the only thing that I wanted to point out is that we didn't use time, right? So it said 20 seconds, 30 seconds. Why was that needed? And so maybe it's useful, question mark? Well, maybe it's useful actually to ask another question about how fast the car was moving during this time. And the "this" is in quotes because we don't know which time we're referring to. So, yeah, or which part of the journey we're referring to. So, anyway, what we're going to do next is look at two perspectives on how fast the car was traveling. And so the how fast question depends on our perspective of position. If we're looking at displacement over time, so looking at how the object moves based from where it's starting to where it's ending only, according to time, then we get something called average velocity. And so displacement, we just think of that as really our beginning and our end, the difference in that. That's all this notation means. And then we divide it by the time that is taken, and we call this a vector quantity. And why is it a vector quantity? Well, because it uses displacement. Okay, and then so because we are reporting a vector quantity, velocity is a vector quantity, we need both magnitude and direction. Okay, and also, well, it would be good to include units, and so the units for velocity, well, I want you to do a little bit of thinking here. The numerator, displacement, we said that was in like meters or feet or something like that, so that's fine, and then time is going to be in seconds or hours. So most commonly when we deal with velocity, we're going to be in units that are like meters per second, feet per second. We could even see miles per hour, that's a familiar one for many of us in the US, or kilometers per hour in areas outside of the US. Okay? So, now that was displacement over time, so that was a change in position. The other change in position that we know is distance. Okay, and when we look at distance over time, that is when we get speed, and consequently when we take distance divided by time, that is a scalar quantity because distance is a scalar quantity. And so when we are talking about speed, the only thing that we need to report is a magnitude. Okay, no direction needed, and consequently the units for speed are meters and seconds, feet per second, same thing. Okay, these are the same. Okay, so then how do you tell the difference between velocity and speed? Really, it's that presence or absence of a direction. So if you're given a direction, assume it's velocity. If you're not, then assume it's a speed. Okay, so then now I suppose we should actually probably return to this question and answer that question that wasn't asked of us, but we're going to answer it anyway. We want to find the car's average speed and average velocity. Okay, and so let's go ahead and do that. So if we look at, so we'll do it in order, the average speed. Okay, this was total distance over time, so that was 1100 for the distance, meters, over, and then total time, 20 seconds plus 30 seconds is 50 seconds, and then we divide it, and we get, let's see, punching this into my calculator, 1100 divided by 50, I get 22. 22 meters per second. Okay, and then when I look at velocity, and technically this should be an arrow above it because it is a vector quantity. This was the 854 meters-ish divided by 50 seconds. And so then when I do this, so I do 854 divided by 50, I get 17-ish meters per second. Now that's the magnitude. For the direction, I should say the same direction that I had for the displacement. So the displacement direction doesn't change. Okay, so great, this is fun. Now I'm going to have a series of quiz questions, and you can see them here on the screen. And for each one of these, I'm going to ask you, is it always true, sometimes true, or never true? So hang on for all those quiz questions and have fun with them.